All right. Hello, everyone. Um, we are back for some more studying. Today is going to be hopefully another big stream. Um, Probably going to be going for a while here, but by the end of the day, I don't know. I'm hoping to get fairly far. Hoping to get fairly far. I don't know how far we'll actually make it, but I'm gonna try to get as far as I can. Um, Obviously, like this won't be the same as the last big stream. The last big stream we had, I did I did pan cow, and we did that because we already knew like a majority of the cards. This time we will not be doing that. We will not know a majority of the cards. Um but we're gonna try going for it anyway. Let me lower my volume a little bit so that I'm not like yelling. Um so that hopefully, um I don't know, I feel like every time I do this, every time I come back to this, like this deck, I have just one major problem. I don't want to do the biology section or the biochemistry section. So today, that is a problem that I am hoping to resolve. um I'm not gonna lie, I'm gonna skip the reproduction section. um we are literally going to we're just gonna go we're gonna start from number three. I know that the reproduction section, like it's gonna be too much information. Like I'm not gonna absorb all of it. And literally if I do the reproduction section, I genuinely might last 3 hours on that one section, doing those 65 cards. And it's going to exhaust me. Like I'm already gonna be tired. So I'm hoping that by starting on number three, we can actually, I don't know, we can get ahead of ourselves. Um so we could do number three, and number three might take us a little while. I was trying to make like some kind of like study guide that we can use on the stream that I could just like review. Unfortunately, there was nothing that could give me a good enough study guide for me to use. So, um, yeah, we're just not gonna be able to do that. Uh, and we're literally just gonna go straight into it. Maybe I'll look it up for like I'll look up one last thing before officially calling it a day that I literally just came up with. Um Obviously if I find it, then I will show you guys it as well. Um I just really don't want to I really want diagrams. That's my biggest thing. I want diagrams and I don't want a lot of reading. Um which not even obviously. I thought that with the amount of history that this has, I thought that it would be almost certain that we could find stuff, but it is not, in fact, almost certain. So, what we are going to do, yeah. So, I think I found, uh, I found Leah Forsai cheat sheet, but honestly, that's not even. It's just simply not enough. Um, Embryogenesis. Nothing on embryogenesis. Okay. Uh, okay. MCAT bros. MCAT bros. People always talking about MCAT bros. So let's see. Let's see if they have anything that we can use here. Uh, why would why would MCAT bros lay it out like this? This is like this is like not This doesn't make sense. I'm not gonna lie to you. So I'm just gonna pretend like I didn't even see that. Um, all right. Yeah, so pretty much there's nothing. I can't find anything that is good enough for us to watch. So yeah, we're just gonna start and we're just gonna go as far as we can, starting at three. I ordered them up until six, although I don't know if we're actually obviously now that I'm looking at the numbers, like I clearly have overestimated myself. Like we're already that would mean that we're gonna get through like 400 cards, which is just simply not happening. So like we'll be lucky if we even make it to 250. I'm gonna be honest with you. If we can make it to 250, honestly, we had a good day. Um, but yeah, that's realistically my goal. Uh, and then um, tomorrow we are gonna use tomorrow we're gonna use this deck and these 58 cards in mathematics. Absolutely brilliant. Like, I love these little like this is me copying out because today we're gonna have I'm trying to have a big day. So if tomorrow we come back and I looked a little bit through this deck and it has literally like I don't even know, maybe six, seven cards that are like that are just like powers or like certain numbers put to certain exponents, like what would the result be? And obviously I'm gonna suspend all those cards. So if we do this tomorrow, we're not gonna have a lot of cards, but realistically we'll still end up putting 58. We'll still end up putting in the work for 58, or not the work, but we'll end up putting in work for so like a certain specific amount of cards. Um, and then I don't know what else. I don't know what else we would do. Maybe I might put in some for like these or something. I don't know, something like that. Uh, I just really the thing that has been the most annoying to me. I just want to get it out the way, uh, so that we don't have to worry about this again. Because we keep having these stupid problems with we like I don't want to do biology. I don't want to do biochemistry. So I think that's enough. That's enough of my yapping. All right. Well, let me put on the lo-fi and we can get started. Hold on. Yeah, that actually is the. Let me see if there's any. We kind of have listened to that. Let's see. Um. Okay. All right. Let's see. All right. Let's try this one. Maybe that don't sound. Oh, y'all can't even hear it. Okay. All right. 1 second. There you go. Now you guys can hear all of it. Um. I'll bring the volume up just a little bit. Not that. Maybe not that much. Okay. All right. Well, so we're gonna do biology. Here we go. All right. I don't know why this card. It was they decided to put like the large language models that we use. Like, I don't know why Gemini decided to put this one first. What happens to the secondary oocyte following ovulation? Uh, I think this is misplaced. To be honest with you, I think this one. Let me see if it's possible, because I think this card actually is not. It's not supposed to be here, and that's why it's first. I think that's the problem. I think it's. I generally don't think it's supposed to be in this deck. I think it's supposed to be in the reproduction deck, and it's for some reason here. Um, Actually, I might be completely wrong. I'm gonna be honest. I might be completely wrong. It might genuinely supposed to. It might be supposed to be here. It might be meant to be here, I should say. I don't know, guys. Should we try? Should we just start with reproduction? Damn, bro. I really didn't want to do this, but I guess we'll start with reproduction. We're not. Let me turn off. Let me turn off my reviews. I'm doing my reviews later tonight. We're not doing this right now. We have 93 reviews. I'm not concerned at all. I'll probably do it literally while doing something else. They're not my concern. They're not my main concern at all. All right. Reproduction. Here we go. What does it mean to say that genes are linked? Um, it means that they're inherited together. Or that's what I meant. Like they're likely to be inherited together. Okay. How can recombination unlink linked genes? Uh, hmm. Is it like, is it across chromosomes or something like that? Sometimes only one of them crosses over. How did that make it unlinked though? I don't get it. Okay, hold up. Let me look this up because I'm not understanding how would this unlink it. Also, I really don't understand why it thinks I'm gonna be done with this in 37 minutes. That's like incredibly unlikely. Um, Incredibly unlikely. I'm not finishing this in 37 minutes. Um, Hold up, guys. It's still loading. Sorry. Uh, okay, so the two genes sit. It said, this is what it says. The two genes sit on the same chromosome, close together. So whatever alleles start out on the same strand tend to stay together into the gametes. In your picture, one homolog carries A and B, and the other carries, or capital A and capital B. The other carries lowercase a and lowercase b. So linked is basically saying if a gamete inherits A, it'll almost always inherit B. Both of them are capital. If a gamete inherits capital A, it'll almost always inherit capital B. After crossing over at the chiasma, the homologs are gonna physically swap segments. If the breakpoint falls in the stretch of DNA between the capital A locus and the capital B locus, then the piece carrying B gets traded away while A stays put, capital A stays put. So the strand that read capital A, capital B now reads lowercase a, lowercase b. Or lower, oh my God. The strand that read capital A, capital B now reads capital A, lowercase b. And the partner would be the opposite. That counts as unlinking because before both the capital letters were together. After the crossover, the gamete has a combination that linkage basically said you shouldn't get. The genes no longer reliably travel together, and that failure to travel together is exactly what unlinked means. Okay, so basically what it said, this is like pretty much what I was confused about. The genes are still physically linked. Crossing them over doesn't put them apart or put them on different chromosomes. They're still sitting right next to each other. What changed is the allele combination on that one chromosome, and it's also like the single crossover isn't going to unlink the genes. It's just going to produce recombinant chromosomes for that singular meiosis. Um, so it's unlikely to unlink them because there's such little like or quote unquote little space between the genes. Okay, I think I kind of get that. What does it mean to say that the genes are linked? It means that they're so close together that it's unlikely that they don't get inherited together. Okay, I need to stop saying inherited together. What is a carrier in the context of genetics? It means that in terms of a recessive trait, you carry only one of the alleles, meaning that you're capable of passing it on, but you don't experience, you experience very little to no side effects from that allele. That's kind of like what I said, but I did say I'm gonna say again, just because I said little to no, and it's just none. In a developing embryo, what can the primitive gonads eventually develop into? Uh, this it actually didn't teach me in the last deck. testes develop into testes if you have Y. Okay, all right, that's cool. But how can recombination link? Damn. How can recombination unlink linked genes? Um, if there is a recombination that occurs between the two alleles, then it would be capable of unlinking the linked genes. What does it mean to say genes are linked? It means that they're uh, they're likely to cross over together at the chiasma, and it's unlikely that they don't. What is a carrier? It means they have a recessive allele, but they don't have both. Like both chromosomes don't have that recessive allele, meaning that they don't express the phenotype for the trait for which they express the genotype. I didn't say that they can pass it on, but it's kind of like I know that. I'll give myself hard. In a developing embryo, what can testes for a man and bruh, testes for Y chromosome and ovaries for X chromosome. Um, and what are primary sex characteristics? Uh, I don't know. Sex organs you were born with that developed during fetal development. Uh, Sex organs you were born with that developed during fetal development. Um, what are secondary sex characteristics? Physical changes that occur at puberty. Um, I don't. I'm gonna. I feel like the first part of this is good enough. Like I don't. I'm gonna. I'm gonna not memorize the muscle, facial hair, lower voice stuff because what is an androgen? Yeah, that's what I was thinking. What is which hormone is responsible for the secondary testosterone? What are the two functional components of the testes? These are the Leydig and Sertoli cells. Damn, damn. Where are Sertoli cells? Seminiferous. My buddy. Uh, oh, they are a different type of cell. Oh, they're in the seminiferous tubule. Um, 2 seconds. All right, sorry guys. Uh, okay. See, and it thought we were gonna take 37 minutes, bruh. What are the two functional components of? Okay. What are primary sex characteristics? Sex organs you were born with that develop during fetal development. These are physical changes that occur at puberty. Any of the male sex hormones, like testosterone. How can recombination, if recombination occurs in between, like if the chiasma is between the linked genes, then it's possible to unlink them. What does it mean to say? It means that they're likely to be like if crossover, bruh, when crossing over occurs, they are more, those genes are more likely uh to swap over together than not. It means that they carry one of the alleles, but they don't carry both, so they don't present a phenotype, but they can still pass it on. In a developing embryo, what can the primitive gonads eventually develop into? Um, in a developing embryo, what can so if you have the Y chromosome, it would develop into testes. If you have the X chromosome, it would develop into ovaries. Um, which hormone is responsible for the secondary sex characteristics in men? Testosterone. What are two seminiferous tubules and Leydig cells? Interstitial cells of Leydig. Blah blah blah. Different terminology. Ugh. What are primary sex characteristics? Sex characteristics that you develop during fetal development. Um, physical changes that occur during puberty. What is the function of seminiferous tubules? Sertoli cells help to synthesize sperm. Okay. Okay. What are the two functional components of the testes? Um, what are the two functional components? So the interstitial cells of Leydig and the seminiferous tubules. Um, what is spermatogenesis? Where does it occur? Spermatogenesis occurs in the seminiferous tubules. It's the production of sperm. That's like, duh. Of course, it's in fucking meiosis. It's gamete. Duh. What are the 5 steps of sperm development from stem cell to sperm? Spermatogonium, spermatocyte, secondary spermatocyte, spermatid, and spermazoa. Spermatozoa. It's like, all right, we can remember this one. If it has the Z, it's the last one. And the spermatozoa, we just need to remember that's the last one. Spermatid. How can we remember spermatid? Um, Okay, so is this? Hold up. 1 second, 1 second, 1 second, 1 second. I might cook a little bit. Damn, damn. I need. Okay, this has enough letters for me. I'm gonna be honest with you. Spermatogonium. We're gonna use this. This is the number one. It was close enough to the number one. Good enough for me. Second one. Well, it would be the primary spermatocyte, but primary spermatocyte doesn't happen right away. You gotta turn it. You gotta turn it from something into the spermatocyte. You can't just start with the spermatocyte. So, primary spermatocyte. Secondary spermatocyte obviously comes after primary. Spermatid. How many letters are after sperm? Four. Number four. Spermatozoa. That's just. The only thing I might mess up on with that one is the. I might mess up the name itself. That's the only thing. What is the function of the seminiferous tubules? Um, what is the function of the seminiferous tubules? Uh, what is the function of the seminiferous tubules? Um, it it uh produces sperm cells, spermatogenesis through nourishment by the Sertoli cells. Uh, these are gonna produce testosterone among other male sex hormones, aka androgens. Yeah. Yo. Yeah. Hey, you think you're funny, bro? You think you're funny. Anyways, um, what is the function of the interstitial cells of Leydig? Okay. What is an androgen? Any of the male sex hormones like testosterone? How can recombination unlink linked genes? Uh, recombination can unlink genes if the chiasma happens to occur between the two genes. In which case it would just unlink them. Uh, those are sex characteristics that develop during fetal development. Um, they're they exist at birth. Damn, it wasn't characteristics, bruh. So we have spermatogonium, primary sex, primary. primary spermatocyte, secondary spermatocyte, spermatid, and spermatozoa. What are secondary? Those are physical characteristics that you develop during puberty. Uh, interstitial cells of Leydig and seminiferous tubules. Um, what is the function of interstitial cells of Leydig? Um, these are going to produce testosterone and other androgens. What is spermatogonia? I mean, these are the first stage of um, sperm development. They are the stem cells, and uh, I believe they should still be diploid. Yeah, that's like pretty much what I said. What does it mean to say that the genes are linked? Um, it means that if crossing over occurs, those genes are likely to be crossed over together. These are sex organs that you're born with and that develop during fetal development. What is a carrier? A carrier has one of the recessive alleles, but it does not. It has one of the recessive alleles, so it can pass it down, but it doesn't express the phenotype. A primary spermatocyte is, I think it's still, is it still a, I think it's still 2N, low key. It hasn't split yet, I don't think, right? I don't think it's split. Oh, it's undergone the S. It's undergone S, so it has two chromatids, but it's still 2N. Okay. In a developing embryo, what can the primitive gonads eventually develop into? Um, if you have a Y chromosome, it's going to develop into testes. If you have an X chromosome, it's going to develop into ovaries. What is a secondary spermatocyte? Secondary spermatocyte is, I think for secondary spermatocyte, it's already split. So the the homologous chromosomes have split and they are now 1N. And so it's gone down in ploidy. Yeah. The seminiferous tubules are going to synthesize sperm with the help of uh, and nourishment of Sertoli cells. What is a primary spermatocyte? These are spermatogonia that have gone through the S phase of the cell cycle. Which hormone is responsible for secondary sex characteristics? Testosterone. What is a spermatid? Spermatid is this, I think. I don't know what phase it's gone through. And let me look at this. Okay, so primary spermatocyte is after S phase. Secondary is after meiosis 1. So the homologous chromosomes have and they have split up. Okay, so that means that the spermatids are still normal cells. Spermatozoa have already differentiated. So they're gonna have like their little acrosomes and all that stuff. Um, what is spermatogenesis? Spermatogenesis is hold up, give me 1 second. Okay, so uh, okay, spermatogenesis. It is the synthesis of sperm. Um, it occurs in the seminiferous tubules. Spermatid is after that is the those are one end cells that have already gone through meiosis two, and they each have one single-stranded copy of each chromosome. What is the epididymis? Uh, I think like I think it's something about the bottom of the like testes or something. Oh, damn, it's not. I was like I was getting at something with this, but just not exactly. Where new sperm are sent after development in the seminiferous tubules. Sperm's flagella gain utility, and sperm are stored until where new sperm are sent after development. Uh, what is the path sperm takes as it leaves the body? Okay, so I'm gonna go as best as I can. So we just learned that it goes from the seminiferous tubules to the epididymis. So we have the seminiferous tubules to the epididymis, and then I think from the epididymis it has to travel along some kind of tube. I don't know what tube. Uh, then it's gonna pass through the seminal vesicles, I think, right? And then there's one more that makes it more alkaline. And then I don't even know. I think there's like one more thing. Uh if it starts with a U, something that starts with a U. That's my guess. It's like a terrible guess, but it's something. Epididymis, some tube, aka the vas deferens, I think, right? Am I bugging? I might be bugging. What up? Yeah, I'm gonna say vas deferens. I feel like that's. Then the ejaculatory duct, urethra. Okay, I just didn't. Where the hell is the seminal vesicle, buddy? What? How they have the seminal vesicle in the picture, but it's not. What? What? Is this lying to me? Is this wrong? Now I gotta figure this out. Okay, I need to copy this because I need to understand why wasn't the seminal vesicle included? Is it not part? Um, all right. Well, as it just passes by the seminal vesicle and the prostate gland, then both of those just kind of like release something, but it's not actually like it's not, it doesn't take those, like, it's not exactly part of the route. Like, it's just kind of there and it'll like secrete stuff. Um, okay, so 7 up. So seminiferous tubules, epididymis, vas deferens, ejaculatory duct, urethra, penis. Okay, cool. What is an estrogen? Any of the male sex hormones. What is epididymis? It is the place where sperm is sent and stored after, like until ejaculation, after sperm production. What is a secondary spermatocyte? It is a primary spermatocyte after. be back. Okay. All right, cool. Um, okay, so secondary spermatocyte is gonna be um secondary spermatocyte. Um, it's gonna be primary spermatocyte after meiosis one. So all it's gonna be a it's gonna be one N. It's gonna be like they're finally gonna be haploid. The homologous chromosomes have already split up. Each one has a two-stranded copy of each chromosome. Yeah. All right. Cool. I was kind of nervous about that. I don't know. I'm gonna lie. What are the five steps? That's gonna be spermatogonium, primary spermatocyte, secondary spermatocyte, spermatid, and spermatozoa. How can recombination unlink linked genes? If the chiasma is right between them. Physical characteristics that develop during puberty. Uh, like I'm kind of right and kind of not. So, seminiferous tubules and interstitial cells of Leydig. What is a spermatid? It is a secondary spermatocyte that has gone through meiosis 2 and is an undifferentiated, one stranded, has a one stranded copy of each chromosome. Yeah, literally just missing differentiation. I didn't mention that it's undergone meiosis 2, but that was kind of implied. It just misses differentiation. What is the function of the interstitial cells? Um, these are going to secrete testosterone and other androgens. These are sex organs that you are born with and that develop during fetal development. What are spermatogonia? These are sperm stem cells, or well, stem cells. They have two copies, two single-stranded copies of each chromosome. Um, uh, and yeah. Um, what is a primary spermatocyte? These are spermatogonia that have undergone the S phase. What is the function of seminiferous tubules? These are going to synthesize sperm with the nourishment of Sertoli cells. What is seminal fluid and what is its function? Seminal fluid, I think, is secreted by the seminal vesicles, and these are going to it's going to help create semen. Um, it's going to, uh, what's it called? It's going to create semen, and uh, it's going to make it more alkaline. So, um, like it can survive like more acidic environments. Oh, seminal vesicles, prostate gland, and bulbourethral gland. Nourish/protect sperm. Seminal vesicle, prostate gland, and bulbourethral gland. So it's going to go from the seminiferous tubules to the epididymis, to the vas deferens, to the ejaculatory duct, to the urethra, to the penis. What are three tissues that contribute to the seminal fluid, and what do they contribute? Is this just going to be the same question that we literally just came up with? This is going to be the bulbourethral gland, not that we came up with, but that it said. Bulbourethral gland, prostate gland, and the seminal vesicles. All right, this is a little much. for one card. Fructose, fructose, and alkali product. Fructose and alkali products. The prostate gland is alkali products, and bulbourethral gland is clear viscous fluid. Uh, okay, so seminal vesicles are realistically bulbourethral is gonna clear viscous fluid to clean the remnants of the urine and lubricate the urethra. Okay, I don't know. We'll try our best. Um, so what is seminal fluid and what is its function? Um, what is seminal fluid and what is its function? Um, it is going to nourish and protect the sperm. Um, what are the three components of a mature sperm cell and what are their functions? Uh, I think so. It has the acrosome. It has the acrosome as kind of like its shield, and then like it helps to like I don't know. I think it's like break into the egg or something, and then it's gonna have like uh, gonna be like I think the acrosome formed from one of the membrane-bound sacs. Then it's gonna have the flagella, and then whatever this part is, it's just like the cell body. I think head where the genetic info is. Mid piece that's filled with mitochondria and the flagellum to generate force for motility. Uh, okay. Um, so we have the seminal vesicle, which is going to provide alkali products and fructose. Fructose, obviously, for nourishment. Alkali products to protect it in acidic environments. Then you have the prostate gland is also going to release alkali products in order to protect it from acidic environments. And then the bulbourethral gland is going to secrete a clear viscous fluid to to clean the seminal fluid, and to lubricate the urethra during arousal. Clear remnants of urine. Okay, all right. What is a secondary spermatocyte? It is one of the stages of spermatogenesis that um, meiosis one has already occurred. So you're gonna have a separation of hmm, not sure, guys. What is a secondary spermatocyte? Yeah, so like I said, it's gonna be split. Um, Secondary spermatocyte has already undergone the reduction in ploidy, so we're gonna have one N. They're gonna still be the homologs have been split up, so we just have a double-stranded copy of each chromosome. What is seminal fluid? It is produced by the bulbourethral gland, the prostate gland, and the seminal vesicles. Its function is to nourish and protect the sperm. What is semen? Sperm and seminal fluid. We have the head. Uh, that contains the head with the genetic info. The midpiece with mitochondria to nourish to provide the energy for the like motor force in the flagella, and flagella for movement. That that's not that hard. What are three tissues? What three tissues contribute to seminal fluid, and what do they contribute? Um, Three tissues contribute. It's gonna be seminal vesicle is gonna provide fructose and alkali products. Uh, the prostate gland is also gonna provide alkali products, and then the bulbourethral gland is gonna provide clear viscous fluid for cleaning the remnants of urine and um, cleaning the remnants of urine and what's it called? Cleaning the remnants of urine. Uh, and lubricating the urethra for arousal. What is epididymis? It's the place where sperm or developed sperm is sent and stored until ejaculation. These are physical changes that occur during puberty. What is a spermatid? A spermatid is uh, these are haploid cells that are not differentiated. They have one single-stranded copy of each chromosome. Uh, and yeah, I think that's it. What is an acrosome? Um, an acrosome is a thing at the front of the sperm, I think. Yeah, allowing the sperm to penetrate eggs, derived from the Golgi. I don't know if I said that earlier. I hope I did. I think I said that. Uh, what is GnRH? Gonadotropin releasing hormone, hypothalamic hormone, stimulates FSH and LH by the anterior pituitary. Uh, um, hmm. Yeah, my face cam is so deceiving because I feel like it's showing my eyes being like so low, and like I just saw like the clip. I'm like looking down, and like I got distracted, and I was like cutting my nails, and it low key looks like I'm just falling asleep. I promise I'm not. Um, gonadotropin releasing hormone. Uh, Stimulates release of FSH and LH. Okay, so GnRH is going to act on the anterior pituitary. It's going to cause Leydig cells to make testosterone, and it's uh, I'm assuming this is the line for LH and this is the line for FSH. Yeah, it is. It literally says that. I didn't notice this out here. That's why I only saw this one. So this is gonna cause this to make testosterone. It's gonna cause this to um make sperm, and then okay. An acrosome is a cap on the sperm head that's derived from the Golgi apparatus. Uh, oh, I didn't say what the function was. So it's gonna go seminiferous tubules, epididymis, vas deferens, ejaculatory duct, um, urethra, and penis. Um, I mean, I would assume that it would decrease. Like GnRH is just gonna go down. Um, Obviously, like it's called your prime for a reason. You know what I'm saying? Tightly regulated until puberty. At puberty, releases impulses to develop. I thought it was gonna talk. I thought it was gonna go a little more in depth into like the older ages and stuff. You know what I'm saying? Tightly regulated until puberty. At puberty, releases impulses to develop secondary sex characteristics. Um. Uh. GnRH is. Uh. Yo, once again, it looks like I'm sleeping, bro. What is GnRH? It looks like I'm sleeping. I burst into being awake. What is GnRH? I need to stop looking down. What is GnRH? It is gonadotropin releasing hormone. Uh, it's gonna be um, gonadotropin releasing hormone. It's basically gonna stimulate the anterior pituitary to release FSH and LH. Uh, it's a hypothalamic hormone. What is an acrosome? It's a sperm cap in the sperm's head in order to like penetrate the egg. Uh, it's derived from the Golgi apparatus. There's gonna be the no, it's gonna be the seminal vesicle, the prostate gland, and the bulbourethral gland. Oh, bumbo. Yo, okay. What do they contribute? Seminal vesicle is going to provide fructose and alkali products. Prostate gland is going to provide uh, are going to provide alkali products and um, the bulbourethral gland is gonna provide clear viscous fluid uh, to clean the remnants of urine and lubricate the urethra during arousal. How does the presence of GnRH? It's pretty stagnant until we get to puberty. It's tightly regulated until we get to puberty, at which it's released in pulses for secondary sex characteristics. In what way does FSH affect the testes? FSH, LH, we know it makes sense. So we know that LH, which is luteinizing hormone, we can write that. Luteinizing hormone. Yeah, I know how to spell hormone. Luteinizing hormone. Because LL only makes sense, LH is going to affect Leydig, the interstitial cells of Leydig. FSH, on the other hand, is not going to affect the interstitial cells of Leydig, and by that rule alone, then we can know that it will affect the seminiferous tubules, which I'm not gonna write out entirely because that's gonna take like 2 minutes. So it's basically gonna induce sperm production. That is literally not a mnemonic. That's just capitalizing all the S's. Like what? Uh, what is semen? Semen is sperm and seminal fluid. What are the three components of a mature sperm cell? It's gonna have the sperm head in order to store genetic information. It's gonna have the mid piece, which is gonna have lots of mitochondria for energy for the flagellum, and then we're gonna have the flagella, which is just gonna allow for motility. Seminal fluid, what is its function? It's gonna protect um, and nourish the sperm. Um, Seminal fluid is going to uh, oh, never mind, we're good. Um, Seminal fluid is uh, it's produced by the seminal vesicle, bulbourethral gland, and prostate gland. Secondary spermatocyte has gone through meiosis one, and as such, it has uh, one double-stranded copy of each chromosome. LH is going to cause the production of testosterone by the Leydig cells. I feel like that's still not a mnemonic. It keeps saying mnemonic. That's not a mnemonic. There's no way that would get me to remember it. That specifically would be the reason why I remember it. I feel like you can get from here to here, but getting from here to here might not be as like commonly simple. Like I think like I kind of know that, but still. All right. Um, I feel like it's not as like common knowledge, I guess, as they're making it out to seem. What are the basic structural components of the female reproductive system? The ovary, fallopian tube, uterus, cervix, vagina. motherfuckers went in order too. My fault. Yeah. All right. That's cool. What is GnRH? GnRH is gonadotropin releasing hormone. It is a hypothalamic hormone. Its function is to cause the anterior pituitary to release FSH and LH. What is the acrosome? It is the sperm cap, derived from the Golgi apparatus that allows the sperm to penetrate the egg. What is the function of the ovary? Produce estrogen and progesterone, fill the thousands of follicles to hold all a female's eggs. What are the basics? So we have the ovary, fallopian tube, uterus, cervix, and vagina. What is a follicle? Multi-layered sacs that contain, nourish, and protect the immature ova. Contain, nourish, protect. What two hormones? Estrogen and progesterone. Which hormone is responsible for secondary sex characteristics in women? Estrogen. What three things does estrogen do? Female secondary sex characteristics in the embryo, stimulates development of the female reproductive tract, and establishes endometrium each month in preparation for implantation of a zygote. Establishes the endometrium each month in preparation establishes the endometrium each month in preparation What is the function of the ovary? What is the function of the ovary? It holds thousands of follicles. It produces estrogen and progesterone. Uh, Thousands of follicles to hold all of the women's eggs. Oh, that was it. Okay. What is a follicle? That contain, nourish, and protect. Estrogen. What is the function of progesterone? Maintains endometrium. What three things does estrogen do in females? It is responsible for the secondary sex characteristics. It is three things. It is responsible for the establishment of the female reproductive tract during development, during like fetal development, and one more. Stimulates the development of the female reproductive tract. Establishes the endometrium each month. What is the endometrium? It's like the lining of the, yeah, the lining of the uterus. Okay. What is a follicle? Follicle is the multi-layered sac that contains, nourishes, and protects the eggs. What is the function of progesterone? Um, progesterone is going to progesterone is going to um, what is the function of progesterone? Um, what is the function of progesterone? It's gonna protect the endometrium, like basically maintain it. There's gonna be the seminal vesicles, which is gonna provide fructose and alkali product. Then prostate gland, which is gonna provide alkali product, and bulbourethral gland, which is gonna provide clear viscous fluid to clean the remnants of urine and lubricate the urethra during arousal. How does the presence of GnRH change as we mature? Um, uh, how does the presence of GnRH? So it's tightly regulated until you get to puberty, but after puberty, like once you're in puberty, it's released in pulses to develop secondary sex characteristics. It helps induce the development of secondary sex characteristics in the embryo. It stimulates the development of the female reproductive tract, and it's going to establish the endometrium, aka build it. Yes, during menstruation, yes. What is the endometrium? It is the inner lining of the uterus. It causes uh, Sertoli cells to begin producing sperm. What are the two functions of the endometrium? Prevents the walls of the uterus from sticking together. It's maintaining its what? Its patency. Is that? Hold up. slightly wrong. Patency, uh, patency just means being open and unobstructed. I guess I might as well fix the spelling on maintaining. Prevents walls of uterus from sticking together. Second half of the cycle. Okay. Estrogen causes production of testosterone. It is a hypothalamic hormone, which is going to uh, hypothalamic hormone. Hypothalamic hormone is going to cause release of FSRH, not FSRH, FSH and LH by uh, by the anterior pituitary. A follicle is multi-layered sac that protects, nourishes, and contains contains the immature ova or eggs. What is an acrosome? It is the cap of the sperm that allows it to penetrate the eggs. Um, Acrosome is going to be derived from the Golgi apparatus. Um, Estrogen and progesterone. Progesterone is going to maintain the endometrium. This is going to be the ovaries, fallopian tube, uterus, cervix, and vagina. What are the two functions of the endometrium? Um, okay, I forgot the first part of the number one, but the point is to prevent the walls from sticking to one another, um, and to ensure that it's like open and unrestricted. And then during the secretory phase, it prepares for the implantation of a blastocyst. If not, then it would the lining is going to shed as menstruation. It becomes blood vessel rich tissue. Oh, there was no first part to number one. Okay. What is the function of the ovary? It's going to um. Did I just do this? Um, to protect, nourish, and contain the like thousands of eggs. It's also going to produce progesterone and estrogen. I think I'm looking myself hard. I feel like I didn't get that good enough. What three things does estrogen do in females? Estrogen is going to um, hmm, it's gonna it's responsible for inducing secondary sex characteristics in the embryo. It can stimulate the development of the female reproductive tract, and it's going to induce the establishment of the endometrium. What are the two functions of the endometrium? prevents the lining from sticking to one another, and it also is going to, in the secretory phase, it's going to um, become blood vessel rich tissue that uh, blood vessel rich tissue that's blood vessel rich tissue to prepare for blastocyst implantation. Um, if not, then the lining is shed as menstruation. Um, I feel like I kind of described it earlier. No, my buddy. Oh, 1 second. Okay, so ovary into the abdominal cavity to the fallopian tube to the uterus. Okay, so um, okay, it is the inner lining of the uterus. What is oogenesis? It is the uh, all right, hello, hello, hello. I feel like it's still not. All right. Okay, yeah, that looks a little more right than how we had it before. Oogenesis is just the production of the eggs. In what three ways are oogenesis? I'm gonna suspend this, bro. It's just the production of eggs. I should suspend spermatogenesis when I get it. When I the next time that I get it, I'm gonna suspend it. I'm not gonna keep reviewing what is spermatogenesis. What's what is the path an egg takes? It's gonna go from the ovary to the abdominal cavity to the fallopian tube to the uterus to the endometrium. Okay. What are three ways that oogenesis is different from spermatogenesis? Okay. Okay. So we're gonna take. We're just gonna. I'm gonna be back in 5 minutes. Okay. Um, we should be back. Uh, okay. So, just for fun, give me 1 second. We can do the Wordle. We can do the Wordle and the Wordle, and then we can go back into what we were doing because we were going for like we're at like 2 hours right now. So once we hit 2 hours, we'll go back. Um. Uh. Right. We'll hit a little irate. Um. Uh. Hmm. It can't be. It can't be something like that. I could put like tiara, and that might help expose, but that might be too little. I kind of want to do it just to figure out the placements. But okay, so we know there could technically be an O or a U. Let's say I think that's a pretty um it could be this is possible. Damn. Okay, so we know now it's XIXER. It could be a mixer. This is possible. This is really rare, but damn. Okay. It could be a filer. Damn. It could be a cider. A a what? A what? What is that? A diver? Okay. All right. Um. Um. Okay. This is. Where would this be? This looks fairly because of the edges. That's like I'm like kind of confused here. I might guess like a region, and I might be better off to be honest. Uh, what is this? Let's go. Let's go like. Let's go near. Let's see if it's near Singapore. No. Um. Let's check. Let's check near. It's pretty far. Let's check near Qatar. Actually, let's check Kuwait. Now it's further down. If it's that far down from Kuwait, then this one of the? Damn, I don't think I actually know them. Hold up. It's not Tanzania, is it? Damn. What am I thinking of? What is this? Uh, nice. Um, what am I thinking of? I might put in random guesses nearby. Uh, and then I'm gonna be really upset after this because I know that I probably know this. Oh, I don't know this. I don't know that. I didn't. I never heard of that. Territories are hard to guess. I don't have them memorized. Um. Okay. All right. Okay. All right. In what ways are oogenesis different from spermatogenesis? Um. What three ways are oogenesis different from spermatogenesis? Uh. We low-key ran long there, but in what three ways? I don't know. Finite number of eggs. Only by birth, only primary oocytes frozen in prophase 1. Um, okay. A finite number of eggs at birth. At birth, you have primary oocytes that are frozen in prophase 1, and then your secondary oocytes get frozen in metaphase 2, waiting for fertilization. Estrogen. A follicle is a multi-layered sac that protects, nourishes, and contains the ova. What is the function of progesterone? It's going to protect the endometrium. What is the function of the ovary? The ovary is going to produce estrogen or secrete estrogen and progesterone, as well as it's going to consist of thousands of follicles to store women's many eggs. What are the two functions of the endometrium? It's going to prevent the the walls of the uterus from sticking to one another, and it's also going to, during the secretory phase of the menstrual cycle, it's going to be secretory. I don't even know the secretion phase of the menstrual cycle. It's going to cause um, hmm, yo, we are actually gonna, yo, at this pace, I'm genuinely gonna reach. I genuinely believes that I'm gonna hit 8:30, which is like 3 hours into the stream, and I've only done one. Wow, I was actually right. We might have to do the mathematics one today or tomorrow. We might need to do that today. Um, I don't know. I'll try to see, because I want to do at least two, but I don't know. At this rate, it's not looking so good. What are the two functions of endometrium? Uh, we have er, the two functions. Yeah, during the secretion phase, uh, it gets blood vessel rich. It becomes blood vessel rich to prepare for the potential for a potential blastocyst, and if not, it sheds the lining as a part of menstruation. It goes from the ovary to the abdominal cavity to the fallopian tube to the uterus to implanted in the endometrium. What three things does estrogen do? So it provides the secondary sex characteristics. It stimulates the development of the female reproductive tract, and in the menstrual cycle, it's going to establish the thickening of the endometrium, like establish the endometrium or thicken the endometrium. Um, so you have a finite amount of eggs, number one. Your primary oocytes are frozen in prophase 1 until they're frozen in prophase 1 until puberty. Then at puberty, your secondary oocytes are frozen in metaphase 2 until they are fertilized. What is a polar body? Cytoplasm split unevenly in oogenesis. 3 small, non-functional polar bodies, leaving one large oocyte. are the two layers surrounding oocytes? Zona pellucida and corona radiata. What is the structure and function of the zona pellucida? An acellular mixture of glycoproteins that protect the oocyte and allow sperm binding to the oocyte. What is the structure and function of the corona radiata? Layer of cells adhering to the oocyte during ovulation. Okay, so it's a layer of cells that adhere to the oocyte during ovulation. It signals for meiosis II completion if a sperm penetrates. Okay. What is a polar body? It's when the cytoplasm is split unevenly during oogenesis. The zona pellucida and the corona radiata. What is a menstrual cycle? It's the process where a primary oocyte completes meiosis I, becomes secondary oocyte. It is a layer of cells. No, and this is the zona pellucida is inside the corona radiata. The corona radiata, because you think about it, right? The zona pellucida, maybe you can't figure it out from this alone, but the corona radiata, it exists on the outside, and as radiata, it has cells radiating from the cell. It's layers of cells radiating from the oocyte. So yeah. Um, what is the structure of the zona pellucida? It's an acellular mixture of glycoproteins that are going to allow the sperm to penetrate, allow sperm binding, protect the oocyte, and allow sperm binding. The corona radiata is going to, it's a layer of cells that forms during ovulation, and it signals when the sperm penetrates for completion of meiosis II. What is a menstrual cycle? It is a monthly process in which the oocytes are going to progress from primary oocyte to secondary oocyte to potentially being fertilized and completing the cycle. What is the structure and function of the zona pellucida? It is a mixture of acellular proteins that protect the oocyte and allow for sperm binding. What is a menarche? Okay. Monarch. What is the basic timeline of menstruation? Okay. So 1 to 14, shedding of the endometrium and the follicular phase. A 14 is ovulation and the LH spike. And 14 to 28 is the luteal phase. Okay, so 1 to 14 is the shedding of the endometrium and the follicular phase. The shedding looks a lot more like 1 to 7, to be honest with you. Maybe I'm gonna add that. One second. Okay, so you have like the shedding of the endometrium, and the follicular phase from days 1 to 14, with the shedding of the endometrium being more like 1 to 7. Then from 14, okay, 14 is the LH is gonna spike and also ovulation. Then 14 to 28 is going to be, it just says luteal phase. I feel like that's not detailed enough to me. But maybe it still has the potential to expand upon that. In what three ways are oogenesis different from spermatogenesis? Um, uh, finite amount of eggs. Um, Before puberty, um, your oocytes are frozen in prophase 1. Uh, During or after puberty, your um, your secondary oocytes are frozen in metaphase 2 until fertilization. What is It's the first menstrual cycle. What is a polar body? It is the unequal splitting of unequal cytokinesis in oocytes. What is the basic timeline? So like 1 to 14 uh is gonna be like the endometrium shedding and what's it called? Uh, the endometrium shedding, which is like more like the first 7 days. Then you're gonna have day 14 is gonna be an LH spike and the ovulation. And then 14 to 28 is just gonna be the luteal phase. I think phase 1, I should have said follicular phase as well, or days to 14, but honestly, that doesn't even really line up, to be honest with you. Yeah, I don't think so. What is it? Oh, it is and follicular phase. Okay, cool. I actually got that right. Like the whole thing, I was just looking at. What is the path an egg takes in the female reproductive system? Um, it's gonna go ovary, abdominal cavity, uh, fallopian tubes, uterus, endometrial lining. What is the structure and function of the corona radiata? Um, what is the structure and function of the corona radiata? Um, um, it's gonna be the structure and function. Uh, it's gonna be layered cells that form during ovulation. They're going to when, like, signal for the completion of meiosis two. What is the menstrual cycle? Um, it's monthly process uh, where the primary oocyte goes into the secondary oocyte, and it's going to it's going to be frozen there until it's fertilized. Okay. I've actually been describing the other thing. Anyone paying attention would know that I've been saying the other card wrong this whole time. But hopefully I didn't skip that to tomorrow. I'm sure anyone watching thought that that was really annoying. What is the structure and function of the zona pellucida? Um, it's going to be an acellular mixture of glycoproteins that allow for sperm binding. It protects the oocyte and allows for sperm binding. The two layers surrounding zona pellucida and corona radiata. The four stages of menstruation. Um, follicular, ovulation, luteal, menstruation. Okay. It begins when endometrium begins to shed. Okay. So estrogen and progesterone fall. Okay, so basically, these two are gonna inhibit GnRH typically. So when these levels start to fall, and the corpus luteum secretes estrogen and progesterone. So that's gonna cause GnRH to be released more when these go down, and it's going to cause FSH and LH to increase. Because you have more FSH, now you're going to have more follicle growth. And follicles are going to release estrogen. Um, they're going to release estrogen, and these low levels of estrogen are going to inhibit GnRH again. So they're going to inhibit and GnRH. And then it's going to cause estrogen to stop, and then estrogen is just going to normally establish the endometrium. Okay, so first thing I need to know, corpus luteum corpus luteum is going to die. Corpus luteum dies, estrogen and progesterone fall. If estrogen and progesterone fall, GnRH is going to be disinhibited. If GnRH is disinhibited, then FSH and LH are going to increase. If FSH and LH are going to increase, then FSH is going to induce follicular growth. The follicles are going to release estrogen, and those low levels of estrogen are going to re-inhibit the GnRH, while also causing the endometrium to start growing. Okay. What are the 4 stages of menstruation? Um, it's gonna be follicular, ovulation, luteal, and menstruation. Basic timeline. So in the first 7 days, you're gonna have endometrial shedding, and the follicular phase is within like the first 14 days. On day 14, you have an LH spike and ovulation, and then 14 to 28, you're gonna have the endometrial growth. Uh, there's gonna be the luteal phase. What is the structure and function of the coronary radiata? The coronary radiata is a layer of cells that forms during adheres to the oocyte during ovulation. It's going to provide a signal for the completion of meiosis 2 if a sperm penetrates. What occurs in the follicular phase? So the corpus luteum is going to die. Because the corpus luteum dies, estrogen and progesterone start to fall. Because they'll start to fall, GnRH is going to be disinhibited. Because GnRH is disinhibited, then estrogen and progesterone are going to increase. Estrogen levels are going to FSH and LH are going to increase. FSH is going to stimulate follicles, which are going to then release estrogen, and then the low levels of estrogen are going to re-inhibit GnRH while also establishing the endometrium. The first menstruation. Okay, I'm gonna give myself in again because I don't think I deserve a good. In what way does the FSH affect the ovaries? It causes the formation of I mean, it stimulates the follicle, I guess, to start producing estrogen, you know, the growth of follicles. What process leads to ovulation? Um, okay, so it's going to produce estrogen. Low levels are going to inhibit FSRH, I mean GnRH, and then as the estrogen levels start to increase, it's going to then cause positive feedback on GnRH. Um, what is a polar body? Uneven splitting. In what three ways? So limited eggs. They're frozen. They're frozen before. Uh, the primary oocytes are frozen at prophase one. Secondary are frozen at metaphase two until what's it called? We're frozen until metaphase two. Like unless they get until they get fertilized. What is the menarche? Um, it is the woman's first menstrual cycle. In what way does FSH affect the ovaries? It stimulates follicular growth. So high levels of estrogen are going to cause positive feedback on GnRH. Greater GnRH is going to cause greater FSH and LH, and then more LH is going to lead to ovulation. What is ovulation? Process by which a follicle bursts, releasing a secondary oocyte. Um, LH is going to cause for er, it's going to cause the follicle to rupture. Um, oh man, I was gonna say that. What is the corpus luteum and what is its function? Um, the corpus luteum is going to I just learned the other day that like they used to inject HCG into the or well, not explicitly HCG, but um they used to inject like a woman's piss into like a specific frog, and the fact that HCG was in the piss if you were pregnant, it was that was their means of figuring out if this is like such a complicated way of explaining it. They would inject the piss, and if the woman was pregnant, it would um it would cause the frog to lay eggs within like 3 to 12 hours, and that was like the old form of pregnancy test. Um, what is the menstrual cycle? The menstrual cycle is a monthly process where primary oocyte completes meiosis one and progresses into secondary oocyte. If it progresses into secondary oocyte, waiting to see if it'll finish meiosis two if it's fertilized. What is ovulation? It is when a follicle bursts due to a rise or a spike in LH. What is the structure and function of the zona pellucida? Zona pellucida is an acellular mixture of glycoproteins that protects the oocyte and allows for spermatocyte binding. In what two ways does LH affect the ovaries? um, LH is gonna it's gonna stimulate high levels of LH are going to cause the follicle to burst. After ovulation, LH is gonna cause increases in progesterone. It's gonna cause the corpus luteum to produce progesterone. Um, So the corpus luteum is going to die. If the corpus luteum dies, then estrogen and progesterone are going to fall. Because estrogen and progesterone are falling, you're going to get disinhibition of GnRH. GnRH, less GnRH means, or no, you're going to have more GnRH. And then more GnRH is going to cause more FSH and LH. And then more FSH is going to cause follicular growth. Follicular growth is going to mean that you're going to get more estrogen. Low levels of estrogen are going to re-inhibit GnRH, and they're also going to cause, and the estrogen is also going to be causing the thickening of the endometrial lining. What is the corpus luteum? It is a burst follicle that produces progesterone in response to LH. What is the menarche? It is the first menstrual cycle of a woman. What is ovulation? It is uh, it's when a follicle bursts in response to LH. It releases a secondary oocyte that first goes into the abdominal cavity before going into the fallopian tube. What are the four stages of menstruation? Follicular, uh, ovulation, luteal, menstruation, like don't know, menstruation. I don't know why. What is the basic timeline? So from zero to the first 7 days, you have endometrial shedding, and then that is also the follicular phase. On day 14, you have ovulation and the spike in LH, and then 14 to 28, you have the luteal phase. What happens in the luteal phase? You're gonna have endometrial growth for sure. Uh, you're gonna have the release of estrogen and progesterone. What else? Progesterone is gonna inhibit GnRH. A question on the luteal phase is definitely like they're gonna start asking me about twins. Like this is gonna be the most crucial piece of information when they ask me about twins. Watch. After ovulation, burst follicle forms corpus luteum. Um, um, the coronary diata is cells that form outside of the cell during ovulation. It signals the oocyte to complete meiosis 2 if a sperm has penetrated. FSH is going to cause follicular growth. What happens in the menstruation stage? That is when the lining is going to shed. So LH is gonna fall. LH falls, corpus luteum stops progesterone production. Um, um, no implantation, which causes the LH to fall. Corpus luteum. So because the LH falls, corpus luteum stops producing progesterone. So the endometrium isn't being maintained anymore. With both estrogen and progesterone low, GnRH is no longer inhibited and the cycle begins again. In what two ways does LH affect the ovaries? So the spike in it is gonna cause ovulation, and then after ovulation, LH causes the corpus luteum to produce progesterone. What happens in the luteal phase? You're gonna have progesterone production. LH is gonna increase. LH is gonna, because of the LH levels, you're gonna have higher progesterone. Progesterone is going to inhibit GnRH, which is gonna um, lower FSH and LH. Uh, I don't know what else. Okay. What process leads to ovulation? Well, I've been in the menstruation cycle. Uh, you're gonna have, because there was no implantation, LH levels are gonna fall, and that's gonna mean that there's low levels of estrogen and progesterone, which means that um, the endometrium is gonna be shed, and it's gonna disinhibit GnRH, and then the cycle starts again. What is menopause? Ovaries become less sensitive to FSH and LH. What up? Let me check something. What process leads to ovulation? Um, okay, so causes high estrogen from the follicular phase. It's going to cause positive feedback on the hypothalamus for GnRH. What is a zygote? What is menopause? So this is when the ovaries become less sensitive to FSH and LH. It causes ovarian atrophy, and causes ovarian atrophy and damn, and it makes it impossible to get pregnant. It is a birth follicle that becomes a corpus luteum, and it begins to secrete progesterone in response to LH. What process leads to ovulation? Um, High estrogen from the secretory phase uh, leads to positive feedback on GnRH, and that causes more LH, which causes ovulation. What is the first menstrual cycle of a woman? What is a zygote? Like an ovum fertilized by sperm. What occurs in the follicular phase? So the corpus luteum dies. Because the corpus luteum dies, we have low low progesterone and estrogen. Um, Low of both of these is going to cause disinhibition of GnRH. Then you're going to get more FSH and LH, and then the FSH is going to cause follicular growth and production of estrogen. Um, then that estrogen uh, is going to cause the maintenance, oh no, the building up of the endometrium. Basically, the sperm only contributes to the genetic information. What happens in the luteal phase of menstruation? Oh wait, hold up, hold up. Okay, actually, I'll be back in 1 second. happens in the luteal phase of menstruation? Uh, in luteal phase of menstruation, you have um, the corpus luteum is being stimulated by LH to produce progesterone. Progesterone is going to inhibit GnRH, uh, which is going to cause for less FSH and less LH. I don't know really what else there is. As like the progesterone that it's releasing is going to cause the maintenance of the endometrium. Yeah. It's when the follicle bursts due to a spike in LH. It releases it into the abdominal cavity and then into the fallopian tubes. Because I'm just trying to make sure I'm not giving too many hints. Yeah, so I already looked at this. I already got it wrong. What is menopause? That's when FSH and LH FSH and LH do what? Um, FSH. Oh, ovaries become less sensitive to FSH and LH. Yeah. Um, they become less sensitive to FSH and LH. So, um, become less sensitive to FSH and LH. Uh, that causes ovarian atrophy and makes it pretty much impossible to get pregnant. It causes higher levels of FSH and LH in the blood. What occurs in the follicular phase? So the corpus luteum dies. It's going to cause a decrease in progesterone and estrogen. It's cause disinhibition of GnRH. It's going to cause follicular increase in FSRH, FSH, and LH, which is going to cause follicular growth. Um, cause follicular growth and inhibition. No, and then FSH um, is going to cause inhibition of FSH and um, okay. What I'm gonna do is we're probably gonna end right here. I think we've gone for 3 hours and 4 minutes. We're gonna end right here. Um, I will finish the nine red cards. I'll finish them off stream. You guys have seen all of them already. I won't do the new ones until tomorrow. Hopefully tomorrow we can go a little faster. We'll try for another big day maybe. But I'll finish these nine off stream and I'll also do the reviews and then yeah, we'll just continue this tomorrow. But thank you everyone for watching. Pretty much I was right on my prediction. It genuinely did take a long time. This just has a lot of processes and lists to memorize, so it makes it harder. But thank you everyone for watching, and bye.